Alright, hello everyone. In this video, I'm going to talk about how to approach number 4 and sort of give you a hint about what the question is asking for. So please try the problem before you see the video. Okay, so the question is saying here I put a cannon and the cannon will launch some bullet. So it's gonna, for example, if my cannon is direct, is pointing it in this way with some angle, and with the velocity v0, then you can see this one will shoot out a bullet and then it will kind of come over and land it here, right? And then if I make this angle slightly smaller, then it will probably just come over and land it here. If I make it higher, if I make the angle higher, then the bullet will go up and then come down. And then if I shoot straight up, it will go up and down. So I can do it in all directions. And then if I just collect all this trajectory, then you will see there is a very nice dome which includes all the possible trajectory. So my goal is to find I want to find what is this dome, what's the function for this dome, for this specific shell. Okay, so for this shell, I want you specifically to prove that this equation. So what's the meaning of this equation? This equation is saying for a specific row, for example, when my row is like here, this z, the maximum trajectory, the maximum z that all the trajectory can ever achieve is this z. Okay, so if the row is smaller, for example, this is 1. When row is 1, you plug in 1, you will get a number. Then you will get a z, and then it will tell you when row is 1, the z here will be a number, and this is the maximum z that you can possibly get throughout all the trajectories. Okay, so this equation is saying find the z max for each row. All right, so let's do that. Okay, so these are all the trajectory, and we want to find the maximum z for all the trajectory. So first, my approach is, let me find trajectory first. And with all the trajectory, I can fix my row and see and try to find my z max for that row. And supposedly this will be that. Okay, so how do I find trajectory? Let me start with my first idea. So how do I find my trajectory? Okay, so let's look at one of the launch here. Okay, in this launch, you can see that in the in x direction, which is the row direction here, we can see that it's constant acceleration. So I am making so we know this row, which is the x that you're used to, will be v0 cosine theta. v0 cosine theta is initial velocity in x direction times t. And where the y direction, which is my z direction in this case, is v0 sine theta t minus 1/2 gt squared. Yeah, if this doesn't seem intuitive to you, you can always, really nicely, use the free body diagram, and then, do this in the cylindrical coordinate to figure this out. Okay, so here I have a row equals to this, z equals to this. I want to get the trajectory, so I want to get the relationship only with the space. Okay, so meaning I don't want the t. Okay, so now I'm going to get rid of it to combine these two equations without t. What I'm gonna do is I'm going to say T is rho over V0 cosine theta. So that's from my first equation. And I will plug it into the second equation to get this. Okay, I'll quickly organize it. And there's no square here. Okay. All right, cool. So this is the trajectory, and let's look at what it means. So it's saying for a specific rho and for a specific angle and also the V0, then I can find out a corresponding Z. So this Z tell you all the Z inside the dome. This is all the Z inside this dome. Okay. So now we have finished our first goal. Now we need to know that now we know all the Z, like all the points inside the dome, right? But for a specific rho, we need to find out the maximum Z. So now in this equation, for a specific rho, I want to fix my rho. And then I know that if I change my angle, some angle will have a higher Z or will have a higher trajectory. So there must be a very nice specific sweet spot angle that can help me that will reach this maximum Z, right? So I want to find that. Okay, so now I'm going to scan through all the angle and see which one will make this to be 0. So meaning I am hitting the maximum. This is the one that will maximize my Z. Okay. So what I'm going to do is I'm going to just do the derivative on this guy. I will leave the calculation to you. And then eventually you will get something like this. Something like this. So meaning this angle is the angle that will maximize. This angle is the angle where you can find the maximum Z, the most maximum Z for that specific rho. Okay, so now all I have to do is really just plug this theta back into my Z, then Z function. Then I will find out, that surface that we are looking for, and that will recover to this equation. Okay. Throughout this process, I'll try to give this logic a little bit more thought so that you're making sure that you understand the meaning of what you're doing for every step. During this process, when you plug it in, you may find this equation useful. Okay, so just let you know, this too might be useful, like when you plug it back in. All right, so that's it. I hope this video is helpful and give you some idea about how to start the problem.